For this lesson, we're going to go through a few examples for problems from your lesson on similar figures and scale drawings. Okay? Now, similar figures, these are shapes that share the same angles, same angle measures. However, they do not share the same lengths of sides. Okay? So what that's going to create are shapes that look the same, but one of them is going to be smaller and one of them is going to be larger. Right? We have an example here where I've drawn out two shapes, and they look very similar, but this one is actually, twice. If you notice each one, we can see corresponding sides, right? That one matches with this one, right? It is getting twice as large, right? Over here, 4 to 8, it's getting twice as large, 5 to 10, okay? So these are similar figures. They look the same, with the exception that one is smaller. Okay? And we will learn that with similar figures, you can use corresponding sides, right? Corresponding sides being the sides that match up, right? So that 3 and that 6, those match up. That 4 and that 8 match up. That 5 and that 10, they match up. So they're corresponding sides. But we can create proportions where we use those corresponding sides, and then we're going to be able to use them to find missing values. So in this example, we see that, I'm comparing 3 to 4. Okay, so I pick two sides from my shape. So I picked the 3 and the 4. Okay, 3 over 4. So I create a comparison comparing this side to that side. Then over here, I take the same sides and I put them in the same order. Okay, so 6 corresponds with 3, so that needs to be in my numerator. 8 corresponds with 4, so that's in my denominator. Notice, okay, 3 and 4, those are from the same shape. 6 and 8, those are from the same shape. But then when I look across, 4 and 8, those are the corresponding sides, and 3 and 6, those are corresponding sides. So we match up and we see, okay, is this proportionate? 3 over 4 equals 6 over 8. Yes, it is, right? They are equivalent fractions. So we're going to use that skill, and we're going to apply it to a few different problems here. Okay. So for number 1, we see we're missing x. Okay. These are similar figures. Okay. And we see, we need to figure out what are the corresponding angles. I'd say 8 and 32. I would say those are corresponding. And then I'd say x and 20. Those are the corresponding sides. So let's set it up. I'm going to set up 20 over 32, okay, and it's going to equal x over 8. And you can always check, all right, 20 and 32, they're from the same shape. X and 8, they're from the same shape. Then I look and I say, all right, 20 and x, those have to be the corresponding sides, are they? Yes, they are. 32 and 8, those need to be corresponding sides, are they? Yes, they are. Okay. So from there, we just need to solve this proportion as we would solve any proportion that we're missing a value. So I'm going to cross multiply here. I'm going to use the butterfly method. So 20 times 8 is 160, and that will equal 32x. From there, I divide both sides by 32, and that's going to get me x equals 5. So x will equal 5 for this problem, okay? And you could even look and say, does this make sense? Well, if I wanted to get 8 to 32, I would have to multiply it by 4, right? 8 times 4 is 32. True. Well, 5 times 4 is 20. So we could check, right, because we could write the proportion out, 20 over 32, does that really equal does that equal 5/8, right? And the way we could do that is, could we turn 5/8 into 20 over 32? Yes, we could. We could multiply 5/8 by 4 over 4, and that would get us to 20 over 32. So you could check it by using your skills with equivalent fractions, and you could say, does this work? Let me plug it in and see if I can manipulate that fraction to turn it into 20 over 32. Okay, for number 2, this one might be a little more difficult because this one has, it's a quadrilateral this time, it's not a triangle, and we have 2 missing values. So how would we take care of this one? Well, it's quite simple. You need to take care of, right? You need to take care of each variable in its own time. So let's first take care of, I'm going to take care of f. You can do either one in either order. Okay? Well, what you need is, you need to pick one side that you know the value for in both. So I know I'm going to work with this 8 and the 6, okay? Because I know those corresponding sides. And then let's work with 21 and f. Okay? So I'll do 8 over 21, okay, equals 6 over f. So again, you can check, right? 8 and 21, same shape. 6 and f, same shape. 8 and 6, those are corresponding sides. 21 and f, corresponding sides. So I cross multiply, and I get 8f, and that will equal 126. Okay, and from there, I'm going to divide both sides by 8. Both sides by 8. I get f equals, let's see, 126 divided by 8 equals 15.75. Okay, so f equals 15.75. So I've discovered what f equals. I still need to find what e equals. Now, I don't really want to work with a decimal in my proportion, so I'm going to stick with that 6 and the 8, right? The 6 and the 8, and I'm going to do the e and the 16. Okay? So let's do 8 over e equals 6 over 16. Okay, so for this, I get, let's check it really quick, make sure we got it. 8 over e, same shape. 6 over 16, same shape. 8 and 6, corresponding sides. E, 16, corresponding sides. So I know that this proportion will work because I've checked that everything matches up. Cross multiply with the butterfly method. Alright, 16 times 8 is 128. Okay, and it's going to equal 6x. Okay, so I would need to divide both sides by 6, and I'm running out of space, so I'll write it over here. X equals 21.3, repeating, or it could be 21 and 1/3. Okay, so for that one we solved. When I miswrote something, this should not be x, this should be e, right? Don't change your variables like your teacher does, apparently. Bad idea. Okay, so e equaled 21.3, and so that's how you'd solve a problem like that where you are missing two variables. Okay, the key for setting up the proportions, one of the ratios you set up, you need to know both values, right? You can't solve a proportion if there are two variables in it, right? So we would never want e and f in the same problem. So that's why I picked the 8 and the 6 both times to use, because that allowed me to have just one variable in the problem. Now, another type of problem is going to test your ability to create a similar figure, right? By using a problem like this. So it says a tree casts a shadow 10 feet long. A 5-foot woman casts a shadow 4 feet long. Okay, how tall is the tree? Now you might go, I don't know. I don't care how tall that tree is. Well, okay, cool beans. But we need to figure it out because you want a good grade. All right, so what we need to do is we're going to set up a similar figure. And how we're going to do this is we're going to just visualize this problem. All right, so Sally Sue here, okay, she is 5 feet tall, right? She is 5 feet tall. Well, she casts a shadow that is 4 feet tall. Okay? She casts a shadow that is 4 feet long. Now, we have a tree We apparently live in Smurfland because our trees are blue. Okay, so we have a tree, and we know that that tree casts a 10-foot shadow. Okay, so we need to figure out how tall is this tree. If we can visualize this, we can actually create a triangle for both of these situations. So for over here, right, we can have a triangle that is 4 feet by 5 feet. Okay? And then for this one, we can create a triangle that is 10 feet by an unknown height there. Right? We don't know that tree, but we can see that we could create this similar figure. Right? We have two triangles. Okay? And so what we need to do then is set up a proportion to solve it. So I'm going to take 5 over 4 equals x over 10. Okay? And again, I check, does this work? 5 and 4, same shape. X and 10, same shape. 5 and x, corresponding sides. 4 and 10, corresponding sides. So we're good to go. Cross multiply, and I get 50 equals 4x. Divide both sides by 4. Sides by 4. And I'm going to get 12.5 equals x. Okay? So 12.5 equals x. Now, the height of the tree, if they're talking about this, 12.5 feet. Make sure you're putting the measurement in, since it is a problem where you are finding a height. So x equals 12.5 feet. So those are some examples that you will see when working with similar figures and scale drawings.